Our next presenter is Mel Benford, VP of Capability from Airbus in Australia Pacific. Today he'll provide us with his take on future science and innovation for game-changing capability. If you could please welcome Mel. Thank you so much.
So thank you and good morning. I have the opportunity to present on how Airbus and our disruption is changing our environment. Whilst the data-driven environment is the future, some of the products that actually support or need some of that data-driven is the space that we're in. I'll touch on a number of activities that'll lead to one of the ones that we've been working here with DST Group and some of the researchers, and through our strategic research alliance that we signed in 2015. So it's really exciting to bring some of that the information together. So before I start with the main presentation, so what does Airbus do in Australia? Not surprisingly, we make things fly. With around 1,700 staff in Australia and New Zealand, with presences on 4 locations, 8 military bases. We primarily support the Australian Defence Force and the Royal New Zealand Defence Force, covering Tiger, NH90, MRH90 support, and P3 and C-130 for both the Australian and New Zealand fleets. We also sell and support those new Airbus helicopters to the civil market. In fact, we just sold one recently where an interesting businessman in New Zealand decides that he wants to take his golf partners from golf course to golf course. So it's amazing, those VIP helicopters that are out there. And with growing opportunities in the space sector, following the formation of the Australian Space Agency, we're also providing more services and offerings to our customers interested in satellite and Earth observation data. As we've had this morning, the Next Generation Technology Fund has invested in the development of the Defence CRC for Trusted Autonomous Systems in Brisbane, and Airbus supports this. While not a partner at this stage, some of the activities I'll present this morning could be, in time, work in that area, and hopefully we can leverage some of those activities in that space. So if I look at the urban air mobility, in the past century, flight connected our planet. Roden Lassefoth, CEO of A-Cubed, a spin-off from Airbus, has said, in the next, it'll reconnect our communities or our battle space. The next few years is going to be a golden era, or another golden era for aviation. Flight is about to get a lot more personal. So battery technology advances has been leading the growth of electric vehicles, combined with autonomy, is going to change the face of aviation in the next 10 years. There are over 20 companies today that are already working in the personal autonomous vehicle space, and the race is on towards a vertiport-supported suburban travel mode in the next 10 years. Vahana, the one shown here, developed with commercially available technology, is on that journey. An 8-engine, multiply redundant, translating wing, single-person electric vehicle is already going flight testing with Alpha 1, and the journey for Vahana to 2022. Wouldn't that be exciting? So Airbus and Audi are also joining forces with Vroom Helicopters, a on-demand to provide an integrated urban transport solution, providing sustainable solutions for city centres. City Airbus, a multi-passenger VTOL, providing optimised aerial transport over congestion cities. Sustainable, 120 kilometres per hour. Air vehicle is proposed with power-on testing later this year. But are we ready yet? Would you sign up? You know, how many of us would already sign up for this capability? So how do regulators and governments deal with the expected disruption? And there's the concept for the Airbus City with Audi, with a pop-up concept for the modular air and ground system. You know, the future is nigh upon us. So unmanned traffic systems. So how do regulators build and work with that? The disruption in the urban airspace. Another company, Altiscope, with Airbus, is basically building the blueprints of the sky. Unmanned traffic system management simulator, evaluating policy options and operational models for our traffic management system serving all forms of airborne traffic, focusing not only on traffic patterns, but geographical and environmental issues as well. by 2030 we'll see a tenfold increase in the number of air vehicles, and tools like this will make it critical in understanding the communications, the policies, the regulations and the operational risk threshold that we're all going to operate in that space. So whilst the vehicles and simulators are in development, where are we with the ecosystem? Well, just to our north, a beta testing of the ecosystem required to operate an autonomous vehicle is underway just to our north in Singapore. Project Skyways, an Airbus helicopters initiative, together with the Civil Aviation Authority and the National University of Singapore, are modelling the future of urban mobility, that last mile delivery. Embodying aviation standards, full autonomy, enabling air mobility for the last mile, urban parcel delivery, demonstrated on the campus of the National University, the autonomous parcel system is completed through an octocopter flying in aerial corridors, enhanced through precision landing systems, allowing for autonomous loading and unloading of parcels and communications for recipients. Access for both the regulator and operators alike. And you can see these sort of concepts transitioning into logistics support in the field for defence. But a game changer that has been the development of the past 10 years is the focus on the final capability. The solar electric powered high altitude pseudo-satellite, or Zephyr, which stands for light wind, integrating the best of structure, solar electric, propulsion and payloads, recently logged a maiden flight of over 25 days, the longest duration flight ever made. The world record is being applied for and hopefully will be confirmed shortly. But just a quick view on this Back to the Future. Check the hand launch and the view to promote this capability. Maiden Flight was undertaken in Arizona. You can see in this flight radar snapshot showing Zephyr as it's maintaining around 60,000 feet, and its flight path in the red, so it was easy to dial into and watch the success unfolding. And with further trials later this year confirmed for Australia, it's pretty exciting to bring this into our local environment. The key capabilities and missions currently identified include wide area surveillance, hotspot monitoring, signal intelligence, networking communications, environment protection and ballistic missile defence. With such a wide array of potential payload, it is with this scope that a joint study into feasible payloads to support the ADF was completed between Defence Science and Technology Group and Australia, Airbus Defence and Space UK and France. The outcome of the study will provide defence stakeholders guidelines into the benefits, possible payloads and capabilities of Zephyr. The study outcome for Airbus will form the basis of a proposal to support dedicated trials to be submitted to the Defence Innovation Program. And Airbus sees that organic developed payloads in Australia integrated with Zephyr-S would aid to the success of such an innovation program. The Zephyr capabilities centre around the three pillars of See, Sense and Connect, initially through military use cases offering some commercial spin-offs and whole-of-government solutions. The Zephyr platform matures and grows to a twin-tail Zephyr-T with a greater payload. Today I've discussed an Airbus view, and you can see some longer-term uses for the Zephyr in the See, Sense, Communicate, as you not only have one platform but multiple platforms in a skyhook for the future. So today I've discussed an Airbus future with the capability of autonomous vehicles and with continued science support how we can be a game changer for the ADF capability. So if you have any questions, we have a couple of the staff from the Zephyr program, one of the guys here, so if you have any particular questions that we can answer, it's right over. Yeah, a quick presentation, yeah.
Right. Hi, Major Tony White from the Mill staff in Edinburgh. I'm just pretty impressive specifications and performance by the HAPS. What about the weight of devices or whatever you decide to put on the platform?
So the question, I mean...
the question is, I suppose that was with an empty payload, was it? Its performance?
Would you like to...
Do you need a microphone for me to put the other ones? Sorry, Nigel Chandler. So I'm part of the Zephyr program, lead for global sales. Yeah, that's what I was thinking. Nigel Chandler from Airbus, one of Mel's colleagues from the UK, and been with the Zephyr program now for 12 months. Our flight activity in Arizona was with a live payload. So the specifics are, we're saying the design specification for any payload, it's a modular payload, so it can either go on the front or there are certain payload bays on the aircraft, is 5 kilograms all up mass. That obviously doesn't include any batteries, casing, and you can think of most payloads being stripped down to the base card level. That gives quite a lot of flexibility. The worst case scenario is overnight when there is only the battery power to power the aircraft, keep the aircraft in the stratosphere, and that's the key part. It has to be in the stratosphere at dawn so that it has that freedom of movement, and we're saying that's an average of 50 watts for the payload overnight. During the day, the power isn't such an issue because you've got a large solar array that will drive that payload and power. You can mission cycle if you've got a power-hungry payload, so you could have 2/3 of the time with a greater power, or for a lot of payloads, particularly electro-optic and IR, we're now at 50 watts would sustain that payload overnight, particularly in an IR mode. So those are our thinking at the moment, but I think the really exciting thing is, where does the technology lead us? We're going in the right direction. The payload on Zephyr-S will have more capacity in the future, and indeed probably does now, but we're keeping our cards close to our chest on that one. We're saying 5 and 50. My view is that will go up. The technology for the batteries, the solar arrays is all going in the right direction. Importantly, for the payloads, all the technology is also going in the right direction. More power efficient, lighter, and a much more efficient design to integrate with the aircraft. So early days, but we actually flew a payload in Arizona and we had pictures during the daytime. It didn't have a nighttime capability, but there's no reason why you couldn't put IR on it.
Okay. Hi, I'm Michelle G from RMIT. I'm really interested in the Zephyr. I've got a couple of questions. So firstly, how do you recover it? And secondly, what are the competing technologies currently?
So recovery is very similar to launch, and it comes down, it spirals down, and basically lands in a flat field, basically in a airfield environment, and then you pick it up on a sled. And competing technologies as a disruptive, I'll let the experts talk about what's out there competing. So,
should I grab that off you again?
Yeah.
Do you want to come up to the podium?
Yeah, come up and join me.
Way,
Bring the expert with me.
This is a warm-up act for land forces where I have got a speaking slot. So just to talk about the competing technologies, in high-altitude pseudo-satellites there are three basic technologies. There is the lighter-than-air technologies. So today a good example will be the Google Loon, is in the stratosphere and uses the stratospheric wind patterns and the altitude to be able to position. Not giving full freedom of movement, but it's using AI to try and predict where it can go in altitude to either move left or right, or sorry, east or west, north or south. And that's about as good as you can get with lighter than air. Going to the future, some people will be aware of something called, or Thales's example being the Stratobus, which is looking at a much larger concept, which is basically to have a much larger platform, lighter than air, that sits there. And then the one that we're talking about with Zephyr, where we believe, and we now know that we are, because we've flown for 25 days, and we only recovered because we need to get that aircraft somewhere else, Australia. And the reason that we know that we've got greater capacity is we saw the battery performance at the end of that. The key part of that is that you're using the Bernoulli effect. It's a winged aircraft, and it is up there in the stratosphere for as long as you can keep it, based on the amount of solar energy you can capture during the day and then how much you can store overnight. So those are the three competing technologies that we're looking at. And at the moment, the reason why we're placing our investment behind Zephyr is because it gives us the greatest freedom of movement, so you can mission determine where that aircraft needs to be, at what time, and also it sits in that interesting area where we've got a lot of experience, which is in unmanned and also in aviation and winged aircraft.
Hi, Jeremy from Clearbox Systems. Just curious how the regulatory side of things works to fly something for 25 days or longer. Presumably the flight path will change. I suppose at 60,000 feet, does it matter?
There are three challenges that I see to getting the very best out of this new technology. The first is keeping the aircraft up, the sky hook, or the hook in the sky as I like to refer to it. I believe we're a long way down that, and actually proving that we can do that for 25 days is a great starting point. Second part is what you can do with it, how you integrate payloads, and then the architectures that go with that. But the point you make is the regulatory, and that's probably going to be the greater challenge. One of the reasons why we've come to Australia to open our first operational site is because of the very close and active engagement we've had with CASA as a regulatory authority. This aircraft can fly under military rules or under civilian rules, and CASA have been very clear that whilst the regulation needs to be developed, this is a great opportunity to work closely together to do that. So initially for this year, we're looking at a limited regulatory set of approvals that will allow us to go so far. And as we gain that portfolio of evidence, which will go against our safety case and proves the safety case, we can start to push that out. So we can really start to push the global capabilities. We are going to be first out there, so we are going to be pathfinding in a lot of areas, and we are going to have to be taking that portfolio of evidence that we're developing both with the UK Military Aviation Authority and with CASA to other aviation authorities around the globe, so we can start to move through into other potential airspaces. And of course there's the UN angle with ICAO as we move towards type certification in the future. This is early days for regulation. We are learning with the regulators, and we're absolutely delighted to be doing that in Australia with CASA.
Yeah, just to follow up, what about on the frequency coordination side of things for the different payloads dealing with, well, in Australia, ACMA?
And again, frequencies are a significant part of this. On the connectivity side, World Radio Conference 19, there is a clear opportunity for high-altitude pseudo-satellites to sit in a combination of geosynchronous, low Earth orbit, and also add another layer which will give us, and I think particularly prepare us well for where we might be going with 5G. That's a whole frequency regulation piece in its own right. The bit that I think we're looking at in a classic UAS sense is the downlinks and the other capabilities, and yes, that again needs to be taken on a case-by-case basis, and again we're down that path of quite advanced engagement with Australia and other nations where we might wish to be operating Zephyr in the future.
So we still have about 5 more minutes for any further questions. You can raise your hands.
Oh, hi there, David Cox from DST Group. I'm kind of interested in solar performance at polar operational attitudes. Is that a problem?
If I understand, it's you're saying can we operate over the poles, and basically what's the latitude limitation of the aircraft? So what I'm saying today is 25 degrees in winter. So that gives us that persistent freedom of movement that comes from maintaining a stratospheric dawn altitude. And in Arizona, the stratosphere was about 53,000 feet. So we said, let's aim to keep it above 55. And I think worst case in those 25 nights that we were up there, we were about 58.5 if you go through Flight Radar 24. Polar orbits are possible. In the winter, they're challenging because there's no sunlight. In the summer, they're absolutely there. The only thing is that I would say we need to understand the stratospheric weather better. Particularly in the Southern Ocean and getting towards the southern latitudes, there are very, very strong stratospheric wind effects, which might mean that we need to be higher up. That's not a problem because we should be able to go higher up if we've got the sunlight to do it. And indeed, one of the records we're also applying for from Arizona is an altitude record. We're above 74,000 feet, which exceeded our previous one, which was just above 72. So, yes, definitely looking for it. If I'm to sort of state an ambition here, I would love to see a circumnavigation pole to pole. It's possible, it just needs to be sequenced with when the sun's available and how we do it, and I would love to see that in the next couple of years.
And one final question before we close this presentation off. Thank you very much, Mel, for that. That was fantastic.